All right, 2.5 is implicit differentiation. Once again, in the library at my house, okay, or your library, it's you to decide. And let's get this Java thing out of here. Okay, now you can see the screen. And explicit is what we usually do. It's y equals. And that's all we've been learning is y equals, then taking a derivative. So this one is explicit, y equals 1 over x. But if we wanted it implicitly, we would multiply x and y together, and the implicit would have the two variables together, the x and the y. But we can only take the derivative with respect to 1. And I say a reminder here, the dy dx is with respect to x. So believe it or not, I have a special guest to do our first one, which is the derivative of x squared. See if you recognize her.
Hi.
Look into the thing.
Hi. I'm Allie. Should I write now? I have to do this.
Do it.
Okay. It's 2x.
Did she do a good job? I think she did a great job. What about you?
I think so.
All right, get out of here.
Okay.
That's it. That's it. You too can have a cameo on my video if you pay me $20. All right. Now comes the new portion. And that's when I'm going to take the derivative with respect to x, but there's only y's in there. So what we're going to do is we're going to say, okay, the derivative is, take the derivative like it would be like nothing. 3y squared. Yes, yes. Nice, nice. I think I just got rabbit ears, but I love bunnies. All right. So, but then we have to use the chain rule and take the derivative with respect to x. So it's dy dx. A lot of times I write that 3y squared times y prime. Okay? So check it out. Just like a derivative, the only thing, because they don't agree, I write y prime. Let's do another one. With respect to x. Well, this is no problem. Derivative with respect to x of x is 1. Nice, nice. But now this one, we're going to just take the derivative like we were taking it before, 3. However, remember, this is y. These variables do not agree, so it has to be y prime. There it is. We could product rule these babies. Let's product rule one. Here's fishing, great, 3y squared, but don't forget, that y didn't line up with the dx that I highlighted, so it's y prime. Now, the x lined up. I didn't actually take the derivative of x. So, plus the second times the derivative of the first. Derivative first of x is just 1. Okay, so we don't have to write an x prime or anything because the variables line up. There it is. If you want to write it nice, I would write something like, I don't know, I guess 3xy squared y prime plus y cubed. You could factor a y squared if you want. You want to factor, go ahead. Enjoy yourself. Actually, I'm going to factor y squared. And it could look like something like this. But this or this is fine. And that's the product rule. Anytime you take the derivative of a variable that's not the one that's under here, you have to put that prime. Or you could write, like I did up here, dy dx or something like that. Next one, another product rule. So it's fishing, great. 3, these are the same. Oh, no, they're not. Watch. dy now. Fishing, great. 3y squared. Okay, no problem. It was with respect to y, so I don't have to put the y prime. Now, fishing great gives freight. Well, now I want the derivative of x with respect to y. They don't line up, so I got to put x prime there. I think you get the hint. I hope. I got other ones to talk about. So here's some guidelines. All right, some guidelines for implicit differentiation. Differentiate both sides of the equation with respect to x. Collect all the y prime terms on one side, or the dy dx terms on one side. Factor it out and divide by the factor so you get something that's y prime equals. That's the derivative. We know y prime is the derivative. Let's try one. Let's try something crazy like this one. Notice we have to now look. It's with respect to x. And the only x in the problem is this. So here we go. Let's take the derivative. Derivative of y cubed, power rule, 3y squared, but don't forget it's y prime because they didn't match. The next one is 2y, y prime, because they didn't match. And the next one's 5y prime because they didn't match. But this one is minus 2x. The variables did match. And if you remember, the derivative of any number is 0. Following my guidelines now, what I'm going to do is I'm going to move all the non-y prime terms. I know I'm a little shaky here, sorry. I'm going to move this guy on the other side. So the non-y primes go on the other side of the equation. Usually the x's, just to let you know, or numbers. Okay, equals 2x. So all I did was move that over. Now it says to factor out the y prime. Y prime, I factor. So I'm left with this bad boy. The bad boy. Equals 2x. A little factoring of the y prime. And now divide everything. So I just have y prime equals. So it'll be y prime equals 2x over 3y squared plus 2y plus 5. Nice. Nice. Right, Rabbit?
Yes.
Okay. So we have this as our derivative. Now, if you remember from past sections, remember we wanted the tangent line at a point, and I always said, well, only use the x, only use the x. Well, if we wanted it at 5, 1, now we got to use both. We got to use the 5 in there and the 1 everywhere there's a y. So that's how you would get that tangent line. You can play with that at home, find out what the answer is. I don't know, 10 over 10, 1. Let's try it's 1. Maybe. I'm just doing it off the top of my head. All right, here's one with a product rule. Oh, yeah. Product rule in it. So now, with respect to x, this one is not the product rule. This one is. So this is going to be 3x squared. I took care of that part. Minus. Well, now I'm going to do the whole product rule in red. So it's going to be minus everything I do here. It's fishing, great, gives freight, or 1. So that's what that product rule turns out to be implicitly. Then plus, I don't want to do, I want to get the red out. No, that was too big. Oh, no, I'm melting. All right, here we go. Then plus 2y, y prime, equals 0. Remember, derivative of a number is 0. How am I doing? So now, get all the y primes on one side and get the others on the other side. So this guy's moving, and this guy, remember to distribute the negative. This guy will move, and that's it. So I'll have negative xy prime plus 2y y prime equals, move that 3x over there, and then move that minus y. So distribute the negative and move it over. Factor out the y prime. Yes, even you can do this. Negative x plus 2y equals this thing. Every step by step. Nice, nice. And now divide. So y prime equals negative 3x squared minus y all over. Divide by that. So it's going to be negative x plus 2y. Done. I might have put 2y minus x, just to keep the positive one first, but you know that doesn't matter. All right, and then here comes your friends. But now we got to use the chain rule, okay? So derivative of sine x, they match up. Derivative of sine x is cosine x. Plus, right now, there's an awesome, like violin song of Michael Jackson's Smooth Criminal going on. I don't know if you can hear it, but it's just like awesome. All right, anyway. You've been hit by a smooth criminal. All right, anyway. Here we go. That's what you hear in the background anyway. So 2 cosine 2y. If I let this equal u, now I'm going to be doing 2 cosine of u. Remember, if I take the derivative with respect to u, the chain rule says I got to do times du. So it's going to be negative, or no, you know what? You guys don't like when I do this. So I'll do it like this. 2 times negative sine u times du. du is that. So we get cosine x minus 2 sine of 2y times 2y prime equals 1. So now, oh, the answer is going to be down here. Nice, nice. So now we got to move this over and divide by what's in front of y prime, which is that. Okay. Oh, I didn't take the derivative. Now I did. So, anyway, let's move it over. It's going to be y prime equals the answer. Why did I have 4? Oh, because 2 times 2 is 4, I guess. That works. So 2 times 2 is 4, so let me write it like this. Cosine, actually I'll move it first. I'm really distracted by this great song, by the way. Not that I'm a big Michael Jackson fan, but it was all violins, which was kind of cool. You know, I suggest you come to the library and listen to that. I think it was on Pandora. Anyway, now I divide by this, and I get that. You might say, well, where do the negatives go? Remember, negative divided by a negative is a positive, so that's where I got it. Trig functions, no problem. All right? Any questions? Uno más, por favor. Oh, wow, that's crazy stuff. I actually have 2 more. Here I go again. 2 more. Evaluate this at that point. Find the equation of the tangent line, but I have to give you a problem. So let's give you a normal line. Holy cow. I thought we were normal. Well, actually, the normal line is perpendicular to the tangent line. And remember, that's opposite reciprocal slopes. Slopes, okay? Slops or slopes. So now I get this. All right, so let's take the derivative. Let's do x fishing, great, gives freight times 1 equals 0. So that means that y prime equals negative y over x. Now I want it, that's the first step. I evaluated it. Now at this point, I want it at negative 4, negative 1. So negative 4 down here, negative 1 up here, and that becomes negative 1/4. So that's the slope. Equation of tangent line, we got that. We're good. Negative 1/4 x minus the x value. What was the x value? Come back. And y minus the y value, and y looks like negative 1, so it's y plus 1. That's number 2. Equation of tangent line. Equation of normal line. Everybody's got to be normal here. So the equation of the normal line would be y plus 1, that's 3, and opposite reciprocal slopes. Yes, yes. There's the opposite reciprocal slope. There it is. I got vacuuming going on. I got lots of stuff going on here. But there it is. Uno más. I don't know if I have time for it on my video. Uno más. Let me see. I'm going to pause it for a minute. Okay, I've got about a minute left. I want to do this problem. This is the problem. X squared minus y squared equals 16. That, you know, is a circle. Now I'm going to take the derivative. When I take the derivative implicitly, I'm going to get 2x minus 2y, y prime equals 0. And when the smoke clears, that means y prime equals x over y. Because the 2's will go out when you set them equal to each other. So that's important. We're going to need that because now what I'm going to do is I want the second derivative. If you notice, it's the second derivative. So I'm going to take the derivative of the derivative. So I'm going to take the derivative of this thing. And it's going to be a quotient rule. So it's going to be y, or I should say d2x over dx2 is equal to, okay, I can't afford to make mistakes here. All right, that's going to be equal to the bottom squared, okay, and then it's the bottom times derivative of top, I'm good, minus the top times derivative of bottom. Now I have another y prime, so I get y minus x y prime over y squared. This guy's an issue. This